Hey, what's up, Algebra 2? So here's the homework that we talked about today. It was 1 through 12, and like I said, I was going to do 1, 3, 5, 7, 9, and 11, all the odds. So I'm going to do the left side of your worksheet, you're going to do the right side, and I try to guide you through all the ones that you have to do on your own in terms of what kind of factoring you have to do. So we've been talking about rational expressions as well as restrictions on the domain. So the top part of this fraction is 4x plus 2. 4 and 2 have a factor of 2, so you've seen me factor that 2 out of 4 and 6. 2 times 2 is 4, 2 times 3 is 6, so the top part of this is me factoring out the 2, and what you notice is that 2x plus 3 now repeats. So 2x plus 3 on top, 2x plus 3 on bottom, those cancel like it's a 1, and your final answer is simply 2. Basically meaning that this whole expression simplifies to 2 no matter what x is, unless it makes that denominator equal to 0. So we talked about denominators making the bottom 0 and wanting to make sure that you restrict that domain. So I took the 2x plus 3, the bottom value, and I set it equal to 0. First step, I'm going to subtract 3 to the other side. I'm going to divide by 2, and so this is the value that you see right here that makes it divide by 0. Negative 3 over 2. If you were to plug that value in for x, your denominator would be 0, and that value is restricted. So basically, this expression simplifies to 2 as long as x doesn't equal negative 1.5. So as you're doing number 2, I want you to think about the same idea, except for this one, they have y in common. That's called the GCF. Take that y out, simplify it, and we'll check it in class tomorrow. 3 and 4, these both flex that idea of GCF, greatest common factor. So what I've done is I've looked at the top of this numerator, 20 plus 40x. They have 20 in common. So I divided 20 on each of these, and I get 20 times 1 plus 2x. Now the bottom has 20x as well. The 20's cancel, leaving simply 1 plus 2x over x. So if you take 20x and set it equal to 0, which I'll kind of demonstrate real quick. If you set 20x equal to 0 and you divide the 20 over, 0 divided by 20 is 0, so that means that if x was 0, it would make the denominator 0, which is an unrestricted, it's a restricted value. It's undefined if you plug that value in. So try the one on the right, try to simplify GCF, and I'll go ahead and tell you that the bottom is called difference in perfect squares. So look at our notes today to see if you can try that one. Multiplication. So we're trying to state any restrictions on the variables. So what I've gone ahead and done, and I'll kind of move these out of the way that you can see what I've done to work this problem. The first thing I did was look for what I can factor. 5a plus 5, they both have 5 in common. That's what we call a GCF. If you take 5 out of 5a plus 5, you get 5 and a plus 1. And if you take 10 out of 10a plus 10, you get 10 and a plus 1. So that is the idea of a greatest common factor. So now I'm looking for anything that matches. This 5 can cancel with this 5. This a plus 1 can cancel with this a plus 1. This a can cancel with this a. And all that is left is the 10 right here that I took out of the top right part of the fraction. So your final answer is 10, but that's only if you didn't plug in an a value that becomes undefined by dividing by 0. So let's take a moment to look at a plus 1 and think about what makes that 0, and that would be negative 1. Along with this other value, a can be any number, but if that number was 0, well then we'd be dividing by 0 and that'd be a problem. So our final answer is 10 when we simplify this, but that's only if a can't equal negative 1 or 0. So think about this one over here, factor and cancel considering greatest common factor, and we'll check that one tomorrow. Number 7 and number 8 both have a lot of greatest common factor problems. So as you follow this line over here, I'm pointing at this 2x minus 4. That's really the only type of factoring you have to do on number 8, and that's how you can start canceling things. But for number 7, it's got a lot more going on. Actually, all 4 of these have something that I can take out. 5 and 20 both have 5 in common. 5 divides by 5 to give you 1. 5 divides into 20 to give you 4. Same thing here. 7 goes into 7 and 35. 3 goes into 3 and 15. And 10 goes into 10 and 40. So what you've seen down here is me dividing out all of the greatest common factors and then taking a moment to cancel everything that matches. Y plus 5 cancels with this y plus 5. This 5 can cancel with part of this 10, but there's still a 2 there left over. So I've taken a moment to talk about restrictions. I'll highlight that in yellow for you. What makes y plus 5 0 would be negative 5. What makes y plus 4 equals 0 would be negative 4. So these are values that are restricted because if you plug them in, you'll be dividing by 0, which you can't do. So my final answer is everything that doesn't cancel. I have the 7. I have y minus 4. You notice I have a 6 here. That comes from the 2 left over from the 10, simplified by the 5, as well as the 3. Those are multiplying together to give you 6. This y plus 4 didn't cancel with anything, and that's why it's still part of your answer. Try number 8, and we'll check that tomorrow in class. A few more. We talked about division in class today. Division is very similar, but you have to remember that you have to multiply by what's called the reciprocal. The reciprocal means that 21x over 12y to the fourth, if I want to divide by this fraction, it's easier just to multiply by them flipped. So if you notice, I've taken a moment to flip them where they're no longer in the same position, but the numerator is now the denominator and the denominator is now the numerator. 7 can cancel with a few things. So 7 and 21, that really reduces to 1/3. So that's why you see me cancel a little bit there with a 3 still left in the bottom. Y to the 5th, y to the 4th. If you remember, we talked about power rules. Let's subtract 4 versus 5. There's 1 more in the bottom. So that's why you see 1 extra y in my answer. Same thing with x to the 4th. There's an x here. 4 minus 1 leaves 3. And that's why you have x to the 3rd in the top. I've taken a moment to talk about restrictions. Restrictions means you can't divide by 0. So in this problem right here, there's a variable in the denominator, y. Well, if y was 0, 24 times 0 to the 5th would be 0, and you can't divide by 0. So that's a restriction on the domain. Same thing with x. If x was 0, it would cause the whole fraction to become 0. You'd be dividing by 0. So that is also a restriction. Try number 10. Remember to flip your numerator and denominator for the second fraction. Use GCF factoring to factor out anything you can and look for things that cancel. Last two. So the last two have to do with division again, and what you'll notice is that I've taken a moment to factor what's called difference in perfect squares. Numbers that multiply to be 49 but add or subtract to be 0 since there's no b value. That is 7 and negative 7. I've taken a moment to take y minus 7 squared and to write 2 of them, because when you square something it means you're multiplying the same thing twice. The next thing I did is I said, okay, division, we really want to change that to multiplication, but these two values need to switch places, meaning that 5y plus 35 goes to the denominator, y squared minus 7y goes to the numerator. And what I've gone ahead and done is use greatest common factor to factor out the greatest common factor of each one. So starting with this one, 5 goes into 35 as well as 5. So when I do that, I take out a 5 and you're left with y plus 7. However, that's in the numerator now. The bottom is now on the top, and they both had y in common. And so when you take out a y, you still have y minus 7 inside your binomial. Let's look to see what cancels. So I'll kind of show you what I did to cancel that. So I have an x minus 7 that cancels with x minus 7, and I also have one here that goes with this one. You have a y plus 7 that cancels with y plus 7, and so all you're really left with is this y in front and this 5 in front, and that's what your final answer is, y divided by 5. Now anytime you had something that would force you to divide by 0, we have to restrict that in the domain. So right here, 7 would have made this 0, as well as this one. Now, we talked about this a little bit in class. -7 would also have made this top one 0, and that would be a problem since you'd be dividing this whole fraction equal to 0. 0 is also restricted because both of these have y in it. If y was 0, then you'd be dividing by 0. So try number 12, and we'll check this one in class tomorrow. Hope this video is helpful. Good night.